Now we're going to fix the issue we have here, and we see how we can now connect everything to make my sketch robust. Okay, now this two, if I go back to one, this one is my nominal value. Ensure that you create your first sketch using nominal values so that you can use them down the stream. Yeah, let me edit this one here. It should have nominal height, not value. What is, yeah, that's better. Therefore, we know that we are using the scale factor to scale up our model or scale down the model. You can see, can go 0.8, but of course you know why we can't go 0.8, because see, enter value between 1 and 10. Remember when we created the scale factor variable, we said the default minimum to be 1. Okay, now you can guess how to fix this issue. Everything is going to scale. Even this dimension has to scale up or scale down. Therefore, if you select edit, also this dimension here, you have to scale it, and you have to say this one is 60. You have to say it will be scale factor SF there, multiply by 60, like that. And you see now, this sketch, this dimension, as the sketch scales up, it is going to change. This 7 as well. You can say scale factor multiply by 7. I'm using 7 and 60 because I said the first sketch used the nominal values. By the way, you don't need SF here. I just use this SF as a way to demonstrate for you to understand. You can use scale factor direct here. Okay, for example, let me just show you what I mean. Instead of using SF times 7, I can say use scale factor direct there. If this one is 2, this becomes 14. It scales up and becomes 14. You can see this becomes 120. Now my design is now uh, connected to the blueprints, and still I can scale up and down. So say 10. Everything works. Just imagine you do this in even all this detail. When you dimension, for example, when you start to dimension this one here, you give a dimension, then you multiply by the scale factor. If you want to scale up your model, you can say this one scales up. So that's very interesting. Therefore, let me go back and see, ensure that this one here has this function fx and fx. Now I know whenever I change anything, my model will always scale up or scale down. Yeah, like that. Okay, that is how you can use variables in your sketch. And then I like now this one combining them as a folder. Can say variables. For the folder, I like using caps like that. We have variables, we have blueprints, and now we have this one back profile sketch. You don't need to say back profile sketch because the symbol here is enough. When I see that symbol, I can say it's a sketch. Now, next is we have this back one here, back, back. We now go to front and create now this profile. Then from there, we're going now to connect the the front profile or the sketch to the side to create a surface. We're going to create a surface that connects this one here to this one here. Let me just now go back to how it was. Uh, Let me just use that. Yeah. Or for visibility, yeah, green. Because my pen, the pen I'm using is red. Therefore, if you go to front now, what I need is because my sketch I terminated at this point. This is where I terminated at. Then I need to sketch at this point because now that's how you think the thought process of when you are using blueprint. Whenever you terminate, for you now to be able to create a 3D curve, I show you how to do it. The point at which you terminate is very important. Therefore, I'm going to sketch at this point. Therefore, at this point, I can say sketch like that. I don't need a plane. Other CAD softwares, native CAD softwares, you have to go to the front view, this point, and create a plane like that to sketch onto that plane. Here, I don't need to do that. Just select sketch and select what we call mate connector and attach it at this point like that. It's another way of creating a plane on fly. We usually say when you do something inside a sketch or inside a feature is on fly, on fly. Therefore, I can now sketch. I can now go front view. I'm sketching onto this plane, but I'm using a mate connector. It's a way of reducing these features here. You can see I used 11. For now, I've used 11. If you go back to my previous year, you will see about 13. You have to reduce. The more you reduce these ones here, the more your design is someone is able to understand it. Yeah, make it just make your design easy to understand. Reduce a lot of features. Don't bury features. Sometimes you can sketch something, extrude, then extrude cut to remove it. Those are not good practices. Ensure that your design is following all the good practices for design. And now, for me not to trace this curve here, first thing I need this point. I'm going to select that point and project it. Why? Because I want to make sure that the sketch terminates at this point. I'm connecting this to the sketch because I'm going to use a surface and I need them to terminate at the same point. And also terminating at this point, when you start now to scale your model, it will also scale. Okay? Remember what I said. When you are sketching and you have a scale factor, kindly you have to use nominal value, that is 1. It scales down, and as you can see, my sketch is still there. Side profile, yeah, edit, and I'm going to use a spline. I'm going to use a spline. You can use Bezier, the spline point. Bezier is very powerful. It's a model. I think I'll create another model or maybe something else I'll use Bezier. Bezier can use it here, but let me use spline. Then from this point to this point here. Dimension it from this point to this point. Because of time, I'm not going to use the scale factor. Yeah. If you want to know how now to use scale factor, even using a spline, because now it needs a different technique. Just let me know. I can create another video. But for now, let's focus on just modeling the helmet. The tips I've shown you, you can use them even, you can now use them continuously. I don't need now to repeat it because of time. Horizontal there, let's make it horizontal. Make it vertical, not vertical. You can delete this here. I want it to follow that one there. You try to trace this side like that. Yeah, almost there. One tip about spline, do not dimension them before you try to after before tracing the sketch or your blueprints. Do not dimension after. You can see I've done that, then I can dimension them. It becomes the last step. This is on that 8, I can make it 140. Consider you can now start to approximate depending on the values you have, because it's good to make your sketch fully defined. You can see I've just used 3 dimensions, and you can use safety factor as well, scale factor as well to control also the spline. And this one is called side profile. I I have a habit of renaming everything. Yeah, I have that habit. Yeah. Therefore, next is now I need to connect this to this, and I'm going to use what we call loft. There's something I mentioned in my first video, and I said I'll mention why. Remember when I said here, when I was sketching, there's something I was sketching and said ensure it is horizontal. Let me see here. I said, oh, you can see now, when you scale up down, this is what happens. Because now when I scale to 10, this dimension is pushed. Because I used 10, now the dimension was around there. Yeah. Someone might ask, why did you say this one here to be tangent to this? Remember this one here. I want to use what we call a surface. And I want this surface to have a good continuity. This surface here, the back surface, to have a very good continuity to the front surface. You have to ensure that the point at which these two surfaces are meeting, you have to meet at 90. This is called G1, G1 continuity. And I want these two surfaces to be tangent to each other. How do you ensure that? By ensuring that the point you sketch here is how you can create a construction line and ensure this tangency. Very important. If you don't have that, let me just show you so that you can get it. Let me just use this one here. This surface, I used this surface here. I used loft, the one I'm going to show you. This surface, and it has the sketch I'm talking about. If you go back here, then you can see this profile there. These two surfaces, they meet at this edge. You can see this is where they meet, and this surface has to have tangency continuity. They have to be tangent, and we can check this tangency. Let me see if I can do analysis here on fly. Yeah. If you go on the right bottom corner and select the show analysis tool, yeah, and my screen is zoomed a lot. You select zebra stripes. see now, this white, how it has a very good continuity. Yeah, you see my model has followed the best practices in surfacing. This white, they have to have, they must have a very smooth continuity because of this, because of what I'm saying, the tangency continuity. If you don't have tangent here, you see, you might see them having black to black. You might not see black and white connecting, but this can tell you that this model has a very good surface quality. You can see here, a very good example. You don't have tangency. This one is a if your surface was to be like this, you can see this one here and this one has a longer black pattern. This one has a white. Let me just yeah. You can see this one here, black. This is white. You can see if you see something like this surface is not of good quality. But here, when you see here, you can see now this one have connected very well. How do you achieve this? By ensuring that the sketch terminates tangent to the horizontal. And remember, this one here, I've used mirror to this side. Meaning, if I copy, let me just copy this. Show you something. I said I'm going to use this helmet to teach you also some tips and tricks. Yeah, you can as well, if you want to just model the helmet, you can skip a little bit video, but I prefer also to tell you something. I'm looking for offset here, how to offset the surface like that. And now use this again, zebra stripes. You see how surface, how it has a very smooth surface. We usually have about, we have a G naught continuity is whereby two surfaces meet but they are not tangent. Therefore, okay, G1 is like this is a G1 whereby two surfaces meet but they are connected to each other using tangency. It's a tangency there. Okay, G2 continuity. Remember, let me just draw it here. This surface it starts to connect, and these two tends to connect each other. It will have certain radius, maybe, and this will have certain radius, maybe. You realize with G2 continuity is called continuous curvature, is the rate of change of this one here and rate of change is the same. The other, assuming you see how the aeroplanes, how they go down the runway, how they come and connect well like that. This is called G2. But G1 is a change from horizontal tangency. This is a G1. This have I like using that analogy to understand G2 and G1. G2 is like you're not going directly to the plane, doesn't go to the runway. It starts a little bit, then goes like that. Let me just continue. I go back here and cancel this one here. This now profile, I'm going to use what I call loft this. It's a surface loft this to this. Okay, I press Control back to that. You see? Now, what happens here? I want this surface here, as you have discussed, to be normal to this plane. be perpendicular there. Then this surface at this point. This surface at this point, I want it to be also normal here, to be perpendicular. Therefore, I have a surface that looks like this. Okay? Start condition, normal to profile. You see? End condition, normal to profile. But but you can see they are not. It's not so good. I can increase this magnitude here. You can see. Let's try to here. You know, you cannot increase this tangency. The tangency length here is controlled by these values. If you want to have a very small tangency, oops, let's try to escape this. Let me go again, surface this to this. Then this one here, normal to profile, normal to profile. Now you understand why we usually use normal to profile most of the time. It's because of what I have explained. We want to ensure that our surface has G1 continuity. I can put two there. Okay, you see my surface how it is. Go top, yeah. Therefore, if I was not to mirror this the other side, you can test it. You can test. It's not test. But take this, where the mirror button, yeah, it is this to right, outward, merge to that. Let me just hide these blueprints. Also should give us an improvement whereby you can hide a folder and hide everything inside, because now, let me see, can I hide? I can't hide a folder. Yeah, Onshape can give us that improvement. Now let's do another one analysis here. Zebra stripes. Let me just leave it there. You see what I said, what I talked about. Let me go back to this loft, edit loft, do final, remove this none. See, none. This is what happens. Yeah, this one is called G0 continuity. You can see the whites have disconnected like this. They have disconnected completely. Yeah, because we don't have G0 continuity. Okay, therefore, let me go back to analysis, edit zebra stripes. How do I edit? Zebra turn off. Okay, turn off or turn off, turn off. Yeah, and I would prefer here having a longer tangency at the back as well. Therefore, give it to this one here, give it one. That's better. Yeah. Now we have our back side. When we meet next, we'll now continue to the front side. Thank you and stay tuned for more.